Okay, so next, observe that unsafe edges are not in the MST, so we don't really need to prove it because it follows immediately from what we already proved. We already proved that the safe edges together form the MST, right? So, and since an edge is either safe or unsafe, it must be that if there was unsafe edge in the MST, that would be a contradiction to the fact that the safe edges form the MST. So it must be that there is no unsafe edge in the MST. So this is kind of follows directly from the argument we already did. But let me sketch quickly a proof. I'm not going to write it formally because, as I said, we don't formally require it. But again, it's a good idea to kind of get the argument. So let's assume that we have an edge E that is in the MST, right? So now think about the graph. Since E is unsafe, there is a cycle pi where E is the most expensive edge. Okay. So now think about creating the graph G hat, which would be G with all edges of price larger or equal to the cost of E removed. Okay. So if we remove all those more expensive edges, then in this graph what we have is that we have, and now think about computing the MST to G hat, but without E, right? So if you think about it, there is a cycle pi, all the edges in pi are cheaper than E, so all the edges of pi appear in G hat, which means that the MST of this graph the two endpoints of E, X and Y, must be in the same connected component of the minimum spanning forest, right? It's not necessarily true that the graph is connected now, so it's a minimum spanning forest, but X and Y must be in the same tree in this forest, minimum spanning tree in this forest. Okay, and now we are done, right? Because now we can add back all the, well, that readily proved that E cannot be in the MST, right? Because if it was in the MST, we could, so let's try again. What we just proved, we proved that in the MST of this subgraph, there is a path in this MST, let's call it sigma, where the price of the edges are all smaller than E, right? So E cannot possibly be in the tree because then the tree would have a cycle. So that's a bit hand-wavy, but hopefully it convinced you. Otherwise, there was the original argument. We just said, all the safe edges together forms an MST, and we are done. Okay. The reason for this is that to go over this point is because if the weights are not distinct, all the stuff that we've seen works. The problem is that now we might have situation where edges are neither safe nor unsafe, right? They just have this, they can be in this middle state if weights are equal, right? Think about a situation where all the edges in the graph have the same weight 1, then all of them can serve in the MST, okay? And they can have, and then safety doesn't help, but somehow if the number of times you have edges of the same weight is very small, this is still going to be very helpful in computing the trees. Okay, so to conclude this discussion, all the safe edges together form the MST. Unsafe edges cannot be in the MST. That's the point I was